Welcome to Internet Quality Academy. The channel is for the civil engineer, site engineer, and the quality control engineer. In this channel, I'll provide information, knowledge, and the strategies which is required to get success in the construction field. In today's video, I will discuss about what is the basic things or what are the fundamental things a civil engineer must know whenever they are working at the site. It is a huge subject, and part by part I will discuss. In today's part, I will discuss about the reinforcement. What is reinforcement and why reinforcement is required, and what you need to know about the reinforcement to get a more durable concrete. Hi, I'm Kamal Banerjee, a civil engineer and quality control professionals, and I have more than 20 years of experience in India and the international level. Now I'm on a mission to help young civil engineers to grow their career in the construction field. Let's jump into the subjects. And if you are new in my channel, kindly subscribe my channel and hit the bell icon. So whenever a new video I'll upload, you will get the immediate notifications. So first things, what is reinforcement? Reinforcement in concrete construction refers to the incorporation of steel bars or mesh within the concrete to enhance its strength and durability. Now, reinforcement is a foreign material to introduce inside the concrete to make it more durable and strength. Now, we need to know why reinforcement is required in the concrete. The concrete, whenever a concrete member is subjected to an external load, then the compressive stress and the tensile force both are developed inside this member. Now, the concrete has the good amount of capacity to withstand with the compressive stress, but it has negligible capacity of withstand the tensile force. Now, if we are not add any material to withstand this tensile stress, then it will break. To capture this tensile strength or withstand with the tensile force or tensile stress, we introduce reinforcement as a tensile stress. So it will act as a composite material and it will withstand both in compression and in the tension. So this is reinforcement required at site, and this is a reinforcement. Then different types of reinforcement. What is the different types of reinforcement? Then mild tilts, then TMT bar, welded wire mesh, fiber reinforcement, etc. But in widely in the construction, TMT bar is used. Either it is CRS or in the non-CRS. This is corrosion resistant steel or the non-corrosion resistant steel. So these are the different types of steel used in the construction. Then what is role of the reinforcement? That I will discuss. The reinforcement provide tensile strength to concrete unless until we introduce reinforcement into the concrete. Whenever any load is subjected into the concrete membrane in tensile stress, it will break. To withstand with that tensile stress, we introduce reinforcement into the concrete. Another thing, it has the good capacity that it resists crack. Reinforcement help distribute tensile force, minimizing crack widths and controlling the propagation of cracks in the concrete element. If it is not there, then the crack will happen, and this crack will increase and the beam will be break. So it helps to reduce the crack and it's enhance the lifespan. This is the role of reinforcement into the concrete. Then what is the reinforcement placing? Now in slab or beam or column, how we will place the reinforcement, that is also good criteria. The first things, diameter of the bar. Whenever we are placing, we have to check the drawing. This drawing, it is mentioned what is the diameter of the bar. In widely in construction, we use 10 mm, 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, 25 and 32. But it also used in the higher dia also. These are the diameter commonly used in the RCC structure. So first things we need to know whenever we are placing the concrete inside the placing the reinforcement inside the concrete, what is the diameter of the bar. Then spacing. Now what is spacing? The spacing is the distance in between the adjacent steel or the center to center distance. Now in the concrete, we cannot place like anything like two or three reinforcement together. Again, there is a huge gap, and again 4-5 reinforcement. It's not like that. It should be uniformly distributed because the load is distributed to everywhere. The tensile stress will develop in everywhere in the membrane, so it should be distributed equally. evenly. In the drawing, it is mentioned what is spacing, that the center to center distance, that we have to maintain the center to center distance whenever we are placing the reinforcement into the concrete. Now the position where I have to place, maybe suppose I have the beam is 500 depth. Now where I have to place the concrete, the position we have to know. Then position, it has to compression zone, tensile zone, on the shear zone. In the drawing, it is mentioned where you have to place the concrete. Maybe in the tensile zone, maybe in the compression zone, or maybe in the shear zone. It has mentioned clearly. So according to the drawing and according to the position, we have to place the concrete to withstand the compressive force, tensile stress, and the shear force. So these are the reinforcement placing. Now, reinforcement is iron, so it has the tendency to get rust whenever it oxidize in the environment. Now we need to protect the corrosion, to the reinforcement. If corrosion is there, the volume will increase, and this volumetric increase will develop a stress, and the concrete will break. If it is happened, then our concrete durability will be less, lifespan will be less. So we need to protect the reinforcement against the corrosion. It is the key to success in the lifespan of the concrete structure. So how to protect reinforcement from corrosion? This clear cover, we all know that clear cover is required. In this clear cover, we whatever mentioned in the drawing, please do not ignore this one. It is a very essential for the concrete stability and the success. So we have to maintain the clear cover what is mentioned in the drawing. Then we can use the corrosion resistant steel. Yes, of course, this has the property to not get corrode whenever it is exposed to the environment. Or we can do the cathodic protection, CP. So CP system, this also has used to not get the corrosion of the reinforcement, so that we can get the lifespan of the concrete. So corrosion protection also a vital part for the reinforcement. Then how to select reinforcement? See, this is also civil engineer must know how, why 8 mm, why 10 mm, and what is the spacing, why 150 mm or why 200 mm. This has how it is select. This first is structural design, load bearing capacity, environmental conditions, and the durability. All this factor has to be considered whenever we are designing and whenever we are placing the reinforcement into the concrete. The things structural design, load bearing capacity, environmental condition, and the durability. In these things, we need to select the diameter of the bar and the spacing of the bar and the location of the bar. So these are the selection properties for the reinforcement. The next in testing of rebar. Yes, whatever the material is coming at the side, you need to test it, whether it is product is conform or the non-conform, you need to know. So what is the test? First things, you need to do the physical properties. The first things, whenever the steel is coming, you need to check the MTC, you need to check the challan, or you need to check the physically whether there is a rust or not, and diameter you need to check. So what is the physical properties you need to check? That is dimension test. Of course, you need to check the dimension, and this tensile test, elongation test, bend test, revent test. These tests has to perform into the laboratory. So whenever you are getting the reinforcement at site, take the sample and send it to the laboratory for the test. And when the test is coming, you can check with the MTC whether it is matching or not, and accordingly you can release reinforcement for the placing at the site. So these are the physical properties we need to know about the rebar before placing into the concrete. Next is chemical properties. What are the chemical properties we need to know? That the carbon percentage, sulfur percentage, phosphorus percentage, and sulfur and phosphorus percentage, and any other amount of excuse me, any other impurities is there or not. So these also you need to check with the laboratories. Whenever it is coming, send the sample to the laboratory and they will perform this test. And according to the IS 1786 and BS 4449, it has mentioned the criteria how to select and what is the percentages there or what is the properties. So this has to match with the IS code or the BS code and the MTC so that we can accept this. Then coating thickness. Coating thickness is the corrosion resistance. There is a coating, corrosion resistance coating. We need to check the coating thickness and what is the weight of running 1 meter, how much coating is there, that we need to check in order to get success, or in order to avoid any type of corrosion. And the unit weight we required. Why unit weight required? Because see, 8 mm, 10 mm, 12 mm, the running unit meter means the weight per running meter has to check, because it has the properties as per IS 1786. So you need to check what is the unit weight of that steel. And there is a formula, thumb rule formula, d square by 162 is equal to kg per meter. If the diameter is 10, so in millimeter, 10 into 10 by 162, whatever you will get, that will give the unit weight. This is the standard unit weight, and you need to check in the laboratory whether the standard unit weight is achieved or not. Accordingly, you can accept this or not, because there is a tolerance in the code, and if the unit weight within this permissible limit, we can accept this code. So what if the test, the physical properties, chemical properties, coating thickness, if CRS steel is used, and the unit weight, you need to check before placing into the concrete. So this has to check either from MTC and the third party. When both is matched with the relevant IS code, then it can allow for the placing at the concrete. Next, lapping of bar. Now we have standard length, that is 12 meter. We cannot increase or we cannot decrease, but in the site, every time I cannot place 12 meter, it has something, maybe some 6 meter, maybe 4 or 5 meter, like this. So we need to splice the bar, or we have to lap the bar. It is very common. And how to select the lapping? First thing, we need to know what is lap length. Lap length refers to the length of overlap between two reinforcement bars in a concrete structure element. Suppose I have 18 meter span of beam. Now in 18 meter, I don't have one piece of 18 meter bar. Now I have 12 meter, and another I have to make it 6 meter. Now whenever we are lapping, what will be the lap length? This is called is lap length. Now one bar, another bar. What is this length required is called the lap length. Now it is the minimum distance required for the transfer stress from one reinforcement bar to another. So this has to calculate what will be the lap length. So this is the minimum distance. If you make it more, it's okay, no problem, but it should not be the less than the minimum requirement. That in every drawing it is mentioned, or also you can also find out as per IS 17456 and what is the lap length. Now lap zone. Now I must say that we need to splice. Now everywhere we cannot place the lap. Now what is the lap zone? Lap zone allows for the development of bond stress between the bars, ensuring they act as a single continuous unit to resist tensile and the shear force. Now this lap zone to be very precisely chosen. How it can be? That is the loading pattern, bending moment, and the shear force. Any structure, any element, you have to first check this. What is the loading pattern, what is the bending moment is developed due to this loading pattern, and what is the shear force is developing on that member. On that basis, whenever the bending moment is more, you cannot make the lap zone, or whenever shear force is more, you have to provide more shear reinforcement, and whenever bending moment is less, you can provide lap, but again it has to provide a shear member more. So according to the loading pattern and according to the bending moment and the shear force, we need to first finalize the lap zone, and again we have to finalize the lap length. According to the lap zone and according to the lap length, we have to provide the lap. And lap should be staggered, not in all bar in a same area. It should be staggered in a manner to get uniform distribution of the stress. Now, factor affecting lap length: the diameter of the bar, design codes, loading pattern, concrete grade, and concrete cover. This has all the effect on the lap length and the lap position. So lap or the splice zone is very crucial, and we need to finalize as per the loading pattern, as per the bending moment and the shear force, and we have to decide the lap length and then accordingly we have to splice inside the concrete so that the stress can be developed easily and there will be no crack found. These are the lapping. And another things we need to know, that is BBS. What is BBS? That is bar bending schedule. Now, why bar bending schedule is required? In the drawing, it will mention 8 torque, both sides, center, 150. Now, maybe it is 7 meter. How a person will cut the bar? Because it is in the 12 meter bar you will receive at the side. Now you need to cut the bar according to the size. So what is the size? You need to prefer the size, shape, and the angle, everything to the person who is cutting the bar, so he can cut the bar according to our requirement. That is the BBS. And a bar bending schedule is also known as reinforcement detailing schedule, is a document that provides detailed information about the reinforcement bar used in a reinforcement concrete structure. So it is a detailing how I will place the bar and what will be the bar diameter, what will be the bar size, what will be the bar mark, everything to be mentioned. So what are the things? That is first things, bar marking. Now, why bar marking is required? Suppose we need to reinforce a beam. Now maybe in top there is 3 bar, in the bottom there is 3 bar, and the shear force, and maybe the shear force in the shear zone the spacing is different, non-shear zone the spacing is say, so there is maybe 10 bars in the structural element. Now we have to mark the bar B1, B2, T1, T2 accordingly we will know the B1 bar means the bottom bar, T1 means the top bar, maybe B2 means bottom distribution, T2 means top distribution. Okay, then SL maybe stirrups bar. So this way we have to mark the bar so that immediately I will see the drawing, oh, this is a B1, that means it will go in the bottom. Now bar shape and the dimension. In the beam we all know this L shape, right? U shape. So in the drawing it will not show U shape, but you, whenever you are detailing or you are making bar bending schedule, we have to mention the bar shape and the dimension. Maybe dimension is the straight portion is 8 meter, the L portion is 500, this L portion is 500, and together what will be the 800, 500, 500, so 9 meter. So if this 9 meter will be the length, and the person who is cutting the bar, he will cut the bar and bend accordingly the 500, 500. So bar shape and the dimension is very crucial for the bar bending schedules. And then bar length. So what will the bar length? Then bar quantity. Maybe the 9 meter bar you need 60, 70, or how much? If you are not mentioning the how much quantity is required, the person who is cutting the bar or bending the bar, he will be confused and he cannot perform. So bar quantity also you need to mention, and the bar spacing or the center to center distance, and the bending details, how we will bend and what will be the bending length, that is a bending angle, is 90 degree or the 45 degree, or what is the length of bend, that also you have to mention so that the person can bend and accordingly we can place into the concrete. And the bar weight, so every bar to be counted and what is will be the total bar, that is to be mentioned. So these are the BBS what you have to check and what you have to mention in the concrete whenever you are doing any concrete. Accordingly, these are reinforcement requirement. So I hope I have covered everything. If I miss anything, please let me know so that I can also make another content regarding this, and kindly share your valuable feedback so that everyone can get benefited. Thank you very much for watching me, and please subscribe my channel and hit the bell icon so that whenever I upload any new video, you will get immediate notifications. And if you want to know anything about the construction or civil engineering or the quality control, please let me know. I will be glad to bring the new content. Thank you very much.